All right, okay, thank you. Hi, everyone. We shall continue our lecture on sequential circuit design. Okay, sequential circuit design. Right. So, if you go to your lecture note, so this is actually your textbook. So, your textbook, page 402. Okay. And for the lecture note, so I actually summarize all the important information from the textbook. Then I summarize in your lecture note, PowerPoint lecture note. Okay. So what is sequential circuits? Okay, why this topic is so important? Okay, because in our world, okay, in digital system, okay, we cannot run away from sequential circuits. Okay, we have basically two types of circuit. Okay, sequential and combinational circuit. Okay, what makes the difference between the two? Okay, so as a name, sequential. You see the name sequential, the word. So sequential means that it will happen in an order. Okay, following an order. Okay, right? So that's general definition of sequential. Okay, so here is actually the definition. Okay, from the textbook. Okay, what is actually sequential circuit? So basically, sequential circuit usually designed with flip flop. Okay, flip flop or latches. So these two components. Okay, sometimes we call as memory element. Okay, flip flop and latches. So what is actually the difference between flip-flop and latches? Any of you can guess the answer? What's actually the difference between flip-flop and latches? So both have clock. Flip-flop also have clock, has clock, and also latches also has clock. So the difference is actually the flip-flop is edge triggered. Maybe I can type here. Edge triggered. Good. Okay. Maybe I make it smaller. Okay, edge triggered, while the what we call the latches, okay, it's actually it's level triggered. Okay, level triggered. Okay, so what is edge? What is level? So normally, as I mentioned to you, okay, both of these need clocks to operate. So we have discussed about clock in our previous lecture. So basically, clock, ideal clock is like this, lah. Okay, we have a sharp rising and sharp falling edge. Okay, this is rising. This portion we call as rising, and this portion we call as falling. Okay, but for actual clock or ideal clock, I'm not sorry, non-ideal clock, okay, or actual clock, the clock will become like this one. Okay, so this is actually the rising edge of the clock, and this is actually the falling edge of the clock. Right? Okay, so we also know that this Retaman, please please mute your microphone. Okay. All right. So this is actually high level, and this is low level of a clock. Okay, this is what we call as level, and this one we call as edge, rising edge and falling edge. Okay. All right, same as this one. This is the level 1, okay, logic 1, and this is actually logic 0, and this one is rising. Remember the R in your synopsis report. This is F, falling. Similarly like this one, this is F, and this is R, and this is 1, and this is 0. Okay, yeah. So actually, both component, okay, both element, flip-flop and latches requires clock. Okay, but for the flip-flop, it's either positive edge or rising edge or falling edge or negative edge triggered. But for the latch, okay, is either logic number 1 high or logic number 0 low. So it's different. Level sensitive or edge sensitive. Sometimes we call them as level sensitive or edge sensitive. So level sensitive or one edge. Okay. All right. So which are sometimes called as memory elements. So sometimes we call these two as memory element. And then why we call it memory? Because it has an ability to temporarily hold the data, hold information. Okay, that's what we call as hold data. Okay, it can temporarily hold data, which sometimes we call as token. This is important when we go into detail of the lecture. We will always use the word token. Okay, tokens and memory element. These two will be used after this. Okay, so token refers to data, memory element refers to flip-flop and latches. So the purpose of these elements is not really memory. Okay, it's not really a memory like RAM memory, ROM memory, FIFO memory. Okay, instead is to enforce. Okay, enforce sequence means that it is used to make sure that data is coming in, okay, or going out in sequence, one after another. That's what we call as sequence, and that's what make the circuit we call as sequential. So one after another. Okay, so this actually will distinguish, okay, distinguish between current data or current token from the previous token, previous data, and next token. So that's actually the definition. Okay, when you are asked to give the definition or explain something related to sequential circuit, these three elements need to be discussed clearly. Okay, what is actually sequential element and what are the token? Okay, what is actually the previous, the next, and also the current token, and then how the sequential element avoid the data from catch up with it, and then we miss the data. Okay, so we call the flip-flop and latches, sometimes we call as sequencing element. Element that perform the sequencing operation. Okay, sequencing element. Okay, this is actually available in your textbook. You may refer it after finish the lecture. Okay, so what happens if you have circuit without sequencing element? So without sequencing element, okay, the next token might catch up. Okay, mix of data, okay, with the previous token or previous data, and this will give you an invalid data. Okay, that's why we need to have a sequencing element. Okay, that's actually the advantage or the pros, okay, the positive side of the sequencing. But we also have the limitation or disadvantage side of sequencing. Okay, but they can be reduced lah. Okay, sequencing element delays token. Okay, normally it delays token that arrive too early. I think we have discussed this using a timing diagram. If you recall back the lecture that we have discussed before. Okay, then it will delete the token that arrived too early and then preventing them from catching up with previous token. Okay, so to avoid it catching up with previous token, normally the sequencing element, either flip-flop or latch, it will delay that data or token. Okay. However, this will give delay to the token that already critical. Okay, and then decrease the performance of the system. So normally the performance in terms of frequency, okay, F frequency. So this extra delay we call as sequencing overhead. That's actually the definition of sequential circuits and also the parameters that involve. Okay. This is we already discussed. Sequential circuit normally comprises of either flip-flops or latches. Okay. We have a combinational circuit normally combined with element of flip-flop. So combine them together we call as sequential circuit. Okay. Sometimes called memory element that hold data. Okay, we already discussed. Okay. And then we can see here is actually example of sequential circuits. Okay, finite state machine and pipeline. So these two is actually example of sequential circuit. We have CL or combinational logic, okay, here, and also a flip-flop here. So this gives actually a sequential circuit, okay, what we call as finite state machine. Okay. Similarly for our pipeline, okay, a circuit we call as a pipeline. We have combinational circuit here. So in between the combinational circuit, we have a flip-flop or a latch, okay, to make sure the data is not mixed with the previous or with the next token, right? So output depend on current and previous input. So this is actually the characteristics of what we call as sequential logic. Okay, sequential logic. The output of sequential logic depends on current and previous. So maybe we can see from the diagram lah. Okay. So output here. Okay. Maybe I use different color. With this color, okay, green color. So the output here, okay, for the sequential circuit, it depends on the input. Input, okay, input here. Okay, current input. Okay. All right. Wait, maybe I stop the recording.